Hello, I'm Erroneous from Syntef Digital and welcome to this demonstration video of ERDRE, our tool for performing erroneous data repair on time series. In this video I will demonstrate how ERDRE works by taking historical sensor data to train a machine learning model that can repair or replace corrupt sensor data. We often call this model a virtual sensor since it is software producing or estimating actual sensor values. In order to use ERDRE through its graphical user interface, we first have to start the backend server using this command. We can then open the user interface in the browser. First, I want to show how to create a new virtual sensor from scratch. We click on this button to go to the module for creating new virtual sensors. In the list at the top, we can see the virtual sensors that already exist in the system that I have created earlier. Each virtual sensor has its own unique ID. It also contains the name of the dataset, the name of the sensor it replaces, and a performance metric that's called R² score, which is better the closer it is to 1. To create a new sensor, one can either fill out this simple form, or for advanced usage, one can upload a configuration file specifying a larger number of control parameters. In this demo, I'll use option A and I'll make a quick example with a dataset from a CNC milling machine. The training data is already placed in a designated folder in CSV format. And it is the name of this folder that I use as the name of the dataset. Then I'll fill out the name of the target variable that I want the model to learn how to predict. I specify the learning method I want to use, and now we will use a convolutional neural network. We're going to use 70% of the data for training, which leaves 30% for testing the model. I will now have the terminal open to the right so we can see what's happening in the background when I create this virtual sensor. The backend runs through the different stages of the machine learning pipeline and finally trains the model. When the model is done training, the new virtual sensor will appear at the top of this list. To run inference with the model, we click on this button, and then we can choose the virtual sensor that we just created by its unique ID, and we upload a test dataset that we want to run inference on. We check this box to get a plot of the results. The inference is quite fast, but the plotting takes some time. In this plot, we see the predicted values in red. In this case, the test data included the true values for the actual sensor, in which case we can compare the original values with the predicted ones. But if we only had the input data and the target value were missing, we would only get the predicted values. I want to show you one more example of a virtual sensor. This one is created with data from InterQ, where we predict the severity of one accelerometer based on the severity of another one. When the plot appears, we can compare the predictions and the original values, and we can see that the model performs quite well. This tool can also be used by sending JSON requests to an API as an alternative to using the graphical user interface I have shown you now. It's also possible to create virtual sensors directly from the command line, which makes it possible to set up scripts and automation. The source code of our tool is publicly available on GitHub. We have also made some simple documentation that describes how to install and use the tool. Thanks for watching.